Okay, so here we are with combinations. Okay, so a combination is obviously an arrangement of objects, but the key point here is that the order is not important. Whereas in permutations that we've seen earlier, order is important, like for example, first place, second place, third place. This case, the order has no say, it doesn't really matter, okay? In this, suppose you need to pack 3 of your 8 different pairs of socks for a trip. It says here the order in which the socks are chosen doesn't matter, right? So 3 factorial, or 6 groups of socks shown below, would not be considered different. So you would use combinations to determine the number of possible different sock choices. And we have a formula for it, just like we have a formula for permutations. And so for combinations, it would be NCR. C stands for combinations. N is still the total number of objects, and R is still how many objects at a time. Notice the only difference with this formula is that we add another R factorial to it at the denominator of the fraction. So the number of combinations of 8 objects taken 3 at a time would be 8 factorial over 8 minus 3 factorial times 3 factorial, or 56 different types of combinations. All right, so let's do an example of this. Here it says, for her birthday, Monica can invite 6 of her 20 friends. She's got a lot of friends. To join her at a theme park. So if she chooses to invite friends at random, and this is a good indication here, she can choose kids at random. It doesn't really matter, you know, which one's going to be first, which one's going to be invited second, etc. It's just, you know, she wants to invite some friends. What is the probability that the friends Tessa, Guido, Brendan, Faith, Charlotte, and Rihanna are chosen, and order doesn't matter? Not important, right? Just because you're inviting friends, it doesn't say you gotta invite one friend before you invite the others. So we know we're gonna be doing a combination here. So our formula, remember, is C, and it was NCR. And remember, it's n factorial over n minus r factorial. But we also have to add another r factorial. Okay? Now, we know that how many friends are involved? How many total friends does she has? She's got 20 total friends. That's the total number of objects in this case. So that means in place of n, we can replace it with 20. And how many friends can she invite at a time? She can only invite 6 friends at a time. That's your R. That's your how many objects at a time. So we're going to subtract 6 here and add another 6 there. At this point, we can put this in a calculator and get our answer. You can put this in and you're going to get about 38,760 different ways she can invite her friends. So once again, the question, what is the probability that friends Tessa, Guido, Brenda, Faith, Charlotte, and Rihanna are chosen? Well, there's 38,760 combination of friends she could invite. That's a lot. But she only wants to invite, technically, Tessa, Guido, Brendan, Faith, Charlotte, and Rihanna. So there's only 1 out of 38,760. So there's only one favorable outcome, right? Only 1 out of that really matters. That's how we can find the probability. Remember, probability is always written in a fraction form. So we say 1 out of 38,760 combination of friend invites. This is your probability of that set of friends coming to your party. That's a small chance. But there you go. That's combinations for you.